I hope you can see me. I was a little scared at Anyway, my name is Margaux and I study at JCU, and my PhD essentially looks at whether or not coral restoration works in the long term. And for today I'll be presenting some preliminary data about the response of coral assemblages specifically to coral restoration using 4 case studies. Now, I think we can all agree, I hope anyway, that coral reefs are under a lot of pressure at the moment. So whether it is bleaching, or storms, or chroniform starfish, or coral diseases, or any combination of the above, really, underwater reefscapes are rapidly changing. And in some instances, it's changing from looking like this to looking like that, and increasingly as well to looking like this as managers around the world are looking for solutions and switching to active intervention. And coral restoration especially is gaining a lot of momentum in the space of intervention. Obviously, we're all here to do that at the moment. But as Lisa just recently presented, the current evaluations of coral restoration success is still extremely limited, especially when it comes to measuring the ecological processes. And if we get back to the definition of ecological restoration, so not just corals, but anything from forests to wetlands to oyster reefs, it is defined as the process of assisting the recovery of an ecosystem that has been damaged, degraded, or destroyed. And I think a very important point in this definition is that the notion of resilience, which is the capacity of an ecosystem to absorb and recover from disturbances, is very present. And so resilience is a very important part of ecological restoration. And in fact, when we reviewed the main objectives behind coral restoration, we realized that reef resilience was very present. So objective 1 and 2 align with the principles of recovery, objective 3 and 4 align with the principles of resistance, and objective 5 and 6 align with principles of social resilience. So logically, if we were to assess the success of coral restoration in the long term, we'd want to come up with a suite of indicators that relate back to reef resilience in a socio-ecological dimension. And so in the review we published last year, we came up with 10 such indicators. You have 6 ecological indicators in green and 4 social-cultural and economic indicators in orange. And for today's talk, I'll be presenting some results on the structural ecological indicators, which are indicators 1, 3, 5, and 6. Now, we wanted to test those indicators, and I was very fortunate to be able to visit 4 study sites that were not just nice holiday destinations, but also brilliant, well-established long-term coral restoration projects. I first went to the island of Koh Tao in Thailand, where the New Haven Reef Conservation Program has been restoring the local reef since 2007. And what they do there is that they mostly use fragments of opportunities that they've collected on the reefs and either transplant them directly back onto the reef or use a range of different artificial structures. And they use steel frames, electrified steel frames, concrete reef bowls, and glass bottles in concrete. Then I went to the Maldives, where the Reefscaper program is working on the island of Lenda Giravaro, where they're working in partnership with the luxury hotel resorts. And their objective there is not just to restore the coral cover and diversity around the island, but also provide a hands-on experience for the hotel guests that get involved in the restoration project. They mostly use artificial still frames, so these are the same kind of spiders that Frank Mars presented on the first day. And they've been doing that since 2005 and the opening of the resort. I went a little bit further, from Australia anyway, to the Florida Keys, and I surveyed the effort by the Coral Restoration Foundation that I'm sure a lot of you are familiar with. This program's been going on since 2007, and the objectives there are again quite different because in the Florida Keys and the Caribbean in general, the restoration efforts are very focused on restoring endangered species of Acropora, so Acropora cervicornis and palmata. And what they do over there is that they raise those Acroporas in nurseries, and then they transplant them directly back on the reef using an epoxy cement mix, typically. So they do not use any artificial structures, they just transplant the corals back on the reef. And And finally, I went to the island of St. Croix in the US Virgin Islands, where the Nature Conservancy is involved in a similar program than the Coral Restoration Foundation since 2009, well anyway. It's a little bit of a younger project than the Coral Restoration Foundation, but it's been going on for a while. And so similarly to CRF, they put aquaporas in nurseries and then they transplant them directly back on the reef. So again, no use of artificial structures there. So in short, I have 4 study sites in different regions of the world with different objectives, different socioeconomic frameworks, and I thought they were good best practice study sites to kind of compare what coral restoration success meant in the long term. And so at each of those locations, I surveyed the restored areas where the corals have been planted, the unrestored areas, which were just a few fin kicks away, but on the same reef sites, and then what we called reference control areas, which were the best looking sites in the areas according to local experts. So something maybe that they were shooting for when they were doing the restoration efforts. All right, on to results now, and I'll start with pictures because everybody likes pictures and you know they speak 1,000 words. You have examples of 2 of my locations. You have St. Croix in the left-hand side and Koh Tao on the right-hand side, and the restored areas on the top, unrestored areas on the bottom. And as you can see, even if unrestored areas are literally just a few fin kicks away, the contrast between the 2 can be pretty striking. So in St. Croix, you have a cervicornis field that's about 5 years old in the restored areas, whereas in Koh Tao, you have concrete reef balls that are about 8 years old. If we start looking at the different metrics I was looking for, and starting with hard coral cover, you can see that hard coral cover was consistently increased in all the restored areas compared to the unrestored areas, and that was a significant trend at 3 out of my 4 study sites. In St. Croix, the difference wasn't significant, but you can still see that there was a nice trend towards an increase in restored, in hard coral cover in the restored areas. In terms of structural complexity this time, the trend was significantly and consistently towards an increase in structural complexity in restored compared to unrestored area, and that was pretty encouraging. But the story was quite different when we came to look at coral generic diversity. So this time, it was mostly unchanged across all treatments, except in the Maldives, where the diversity was significantly lower in the restored compared to the unrestored areas, and I'll touch on to why that may be a little bit later. Coral health, again, was quite different across the 4 locations. So this graph represents the proportion of unhealthy coral colonies that were surveyed at each of the sites. And I'll start with Koh Tao, where you can see that in the restored areas, the proportion of unhealthy coral colonies was significantly lower in the restored compared to the unrestored areas. And this is driven by less compromised coral colonies in green. Compromised coral colonies were anything from damages from sediments or overgrowth by algae. So there's a possibility that at these sites where coral are transplanted on artificial structures away from the substrata, the corals are a little healthier because the structures are mitigating these effects. If you look at the bottom 2 graphs in the Caribbean, so Florida Keys and the US Virgin Islands, you can see that coral health was worse off in the restored compared to the unrestored area. And this time the significance was driven by higher levels of predation and disease on the coral colonies. And that kind of makes sense since the corals that are transplanted in these areas are mostly endangered aquaporous species that aren't naturally prone to disease and predation. So it's something to keep in mind. Even if hard coral cover is higher at these areas, the corals are not necessarily very healthy. And finally, I came across a peculiar situation when I visited the Maldives, because when I went there was during the mass bleaching event in 2016. And as you can see with the pink bars over there, the proportion of bleached coral colonies were uniformly over 60% regardless of the treatment. And that was a kind reminder that coral restoration, there's only so much it can do when it comes to coral bleaching. Putting it all together in terms of what the effects of coral restoration were on the benthic community composition, again, the results really varied across the 4 locations. So I know this looks busy, but I'm going to run you through it, and we'll start with Koh Tao on the top left. And there, the benthic community composition was distinct in the unrestored area in blue and the control reference sites in gray. But as you can see, the benthic community of the restored area in green sat in the middle of the 2. So there's a possibility that there, the community composition is shifting away from unrestored towards the composition of the reference control areas. And I don't know if you can read the arrows, but that would be driven by increase in structural complexity, coral diversity, and hard coral cover. And that shift between the two might already have occurred in the Florida Keys, where this time only the benthic community composition in the restored area was distinct from the other two. And the community composition of the restored and reference control sites really sat on top of the other. And again, that shift might be driven by increase in hard coral cover and structural complexity. Came to the Maldives, and this time only the community composition in the restored areas is significantly different. So again, a different story. This time, you know, the distinction is driven again by increasing hard coral cover, but also maybe by a lower generic diversity. And in St. Croix, everything was distinct from one another. But basically what I'd like you to take out from those complex plots is that restoration is having a long-term effect on the benthic community composition. And that effect varies among locations and among restoration projects that have different designs. So this is a summary tables with 4 of the indicators. The green cases represent significant positive changes, the red cases represent significant negative changes, and then the blue cases represents non-significant changes. And so what you can take from that is that regardless of the design and the timing and the location, hard coral cover and structural complexity were increased in the restored compared to the unrestored areas. So with plant corals, hard coral cover and structural complexity increases. The highest ratio in increase in hard coral cover was in the Florida Keys of plus 5.25. And that may be due to the fact that natural cover there is naturally low, as well as the fact that they transplant corals in high density plots. And the highest ratio of increase in structural complexity was in Cotao of plus 2.23, and that was the project where a range of different types of artificial structures was used. Looking at coral diversity, it was mostly unchanged except in the Maldives, and I told you I'd get back to that. And I think the reason why that coral diversity was lower in the restored areas is directly linked to their design. So remember that they're tightly linked to a luxury resort. And they want to transplant corals that grow fast and look pretty for the hotel guests. And so they mostly transplant acroporas and fossiloporas, but the diversity of the corals in the Maldives is a lot more diverse than this. So there's a possibility there that we're seeing a trade-off between the ecological and the social, cultural, and economic objectives of the restoration. And finally, in terms of coral health, the results really varied among different locations with different designs. Coral health was improved in Cotao, where they used a range of different structures, and it was decreased in Florida Keys and St. Croix, where only disease and predation-prone acroporas are being used. So my 2 cents advice over there would be to start using, you know, a mix of different species and potentially some artificial structures to kind of like mitigate the impacts of directly transplanting on the substrate. I think there's some very important limitation to this study. The first one being that I really wanted to survey long-term effects, so I went to projects that were already established, and I wasn't able to control for things like the age of the restoration projects, the level of maintenance, or the type of restoration designs, and that was on purpose. The second thing is that I'm measuring changes between restored and unrestored and reference sites, but I'm very much shooting in the dark in terms of baseline. So the fact that we're seeing a significant increase in hard coral cover and structural complexity does not by any means mean that these areas are more resilient. What we urgently need to do is develop baseline targets for coral restoration objectives that practitioners can use to compare across and have a little bit of a guidance of what to shoot for. So examples of these targets could be, for example, a 50% increase in coral cover at the restored site after 2 years, or targets linked to natural recruitment. And finally, that's a very incomplete part of the story. We still need to look at other ecological indicators related to reef functions, such as the effect of restoration on natural recruitment of fish biomass and diversity, as well as the social, cultural, and economic indicators and aspects of those projects. And I think that's it, and thank you very much for having me, to all the partners involved in this.